Good day, 4th grade students. This is Dr. Ammar Salim. Our lecture today is about fixed orthodontic appliances. So what are these appliances? They are devices which have attachments that are fixed onto the tooth surface and forces that are exerted by these attachments using arch wires and/or other auxiliaries. And by definition, the appliances cannot and should not be adjusted or removed by the patient. Currently, most orthodontic treatment is carried out using fixed appliances. The development of these appliance systems began in the USA at the turn of the 20th century, and they have become progressively more sophisticated. Fixed orthodontic appliances are required for the most accurate tooth positioning, as compared to the result from removable appliance. So what are the advantages of fixed orthodontic appliances? First, precise tooth control is possible. Multiple tooth movement are possible, meaning that we can do more than one type of tooth movement at the same time. We can do tipping, bodily movement, intrusion, extrusion, etc. Patient cooperation is reduced in comparison to removable appliance. All types of tooth movement are possible. The disadvantages is that it requires a high oral hygiene requirement. Without proper oral hygiene, we will end up with multiple carious lesions and gingival inflammation. It also affects aesthetics, and special training is needed for the operator. Otherwise, many errors in treatment will happen, just like shown in the photos. It also has an increased cost of treatment as compared to the removable or functional appliances. With fixed orthodontic appliance, there is an increased chairside time for the operator because we need to do all the work while the patient is sitting in a dental chair. The anchorage control is more difficult as compared to the removable appliance. And finally, the possibility of producing adverse tooth movement is greater. Fixed orthodontic appliances are indicated for the correction of mild to moderate skeletal discrepancies, when we need to do intrusion or extrusion of teeth, for the correction of rotations, even those more than 90 degrees, for overbite reduction by intrusion of incisors rather than extrusion of molars, when we need multiple tooth movement in one arch, and finally for active closure of extraction spaces or spaces due to hypodontia. Edward Engel is known as the father of modern orthodontics, and this position is based not only on his contribution to classification of molar relation, but also on his creativity in developing new orthodontic appliances. The first orthodontic appliance that was invented by Engel is called the E-arch. In this appliance, ligatures from heavy labial wire were used to bring malposed teeth to the line of occlusion. The ribbon arch was another appliance that was invented by Engel. It was well adapted to bring teeth into alignment, but at the same time it was too flexible to allow precise positioning of the roots. This appliance was the first introduction of brackets, as shown below, and the wire was made of gold at a dimension of 10 by 20 milli-inch. Later, Engel introduced the edgewise appliance, and this appliance was invented to overcome the deficiencies of the ribbon arch. We said that the ribbon arch didn't allow precise positioning of the roots. So what Engel did is that he reoriented the slot from vertical to horizontal, and he inserted a rectangular wire that was rotated at 90 degrees to the orientation it had with the ribbon arch. And thus the name edgewise. It means rotation towards the edge, edgewise. An Australian orthodontist, Raymond Begg, introduced the Begg appliance, which is also known as the light wire appliance. In this appliance, a modification of the ribbon arch attachment were used. Round arch wires were pinned in the vertical slots, as opposed to the rectangular wire in the ribbon arch. And variety of auxiliary arch wires were used in this system to obtain control of root position. The Begg appliance became widely popular in the 1960s because it was more efficient than the edgewise appliance of that era, in the sense that equivalent results could be produced with less investment of the clinician's time. Developments since then have reversed the balance. The contemporary edgewise appliance has evolved far beyond the original design. It has almost universal use now, which is known as the straight wire appliance. So, how did the straight wire appliance evolve? At the time of Angle, the same brackets were used on all teeth, meaning that we can use the bracket on the central, the lateral, the canine, premolars, or even the molars. In the 1976, William Andrews developed bracket modification for specific teeth, which will be later known as prescription. Now we have specific bracket for each tooth. So we have a bracket for the right central and a bracket for the left central, which cannot be interchanged. And the same is for all other teeth. And the result was the straight wire appliance. To further understand how Andrews invented the straight wire appliance, we need to know how orthodontists managed the standard edgewise appliance. To overcome the limitation of using the same bracket on all teeth, the orthodontist had to do wire bending. They called it the first order, second order, and third order bends. The first order bends are made in the horizontal direction. They are required to make the wire conform anatomically to the labial and buccal contour of teeth. What Andrews did is that he changed the thickness of the bracket base. So for each bracket, there was different thickness. And this would change the in-out position of the tooth. The second order bends are made in the vertical plane. These bends are used for uprighting teeth and paralleling of the roots. To understand second order bends, let's assume that we have a central incisor with an accurate angulation, and this is the accurate one. Placing a standard edgewise bracket along the long axis of the tooth wouldn't change the angulation, unless vertical bends are made in the wire, and these are called second order bends. In the straight wire appliance, they overcome the need for the second order bends by cutting the slot of the bracket at a specific angle. So just by placing the bracket along the long axis of the tooth and placing straight wire, we will have the correct angulation. These are two sets of appliances. The upper one is a standard edgewise appliance, while the lower is a straight wire appliance. You can see that with the standard edgewise appliance, there is no difference in angulation between different brackets, while for the straight wire appliance, each bracket has its own angulation. The last type of bends is called third order bends. These bends are made along the wire and are required to control torque. Crown torque is evaluated by the angle formed by a line perpendicular to the occlusal plane and a second line tangent to the middle of the labial surface of the crown. Positive torque means that the root is palatally inclined, while a negative torque means that the root is labially or buccally inclined. You can see that by twisting the wire or by doing a third order bend, the crown torque is changed from -7 to +7. To achieve the proper inclination of the teeth with a standard edgewise appliance, what we need to do is to twist the wire before inserting it into the slot. And this is a third order bend. In the straight wire appliance, the same inclination can be achieved by changing or varying the thickness of the bracket base. Therefore, we can use a straight wire and obtain the same inclination. To have a negative torque with a straight wire appliance, what we need to do is to increase the thickness of the bracket incisally, and to have a positive torque, we need to increase the thickness of the bracket gingivally. So in a straight wire appliance, or an appliance with a built-in prescription, we would have variable distance from the base of the slot to the base of the bracket. This will give us correct in-out position, or what is known as bucco-palatal or bucco-lingual position. We will have pre-angulated slots for correct mesiodistal tooth angulation, or what is known as tip. And finally, the bracket bases are inclined for correct inclination or torque. The components of a fixed orthodontic appliance can be broadly classified as attachments, arch wire, and auxiliaries. The attachments are fixed to the crowns, and they mediate forces applied by the arch wire and auxiliaries on the tooth. Two major attachments are there. These are bands and brackets, and we have other attachments like buccal tubes, buttons, eyelets, sheath, cleats, etc. The first type of attachments are bands. Bands are rings which encircle the tooth, to which buccal and sometimes lingual attachment are soldered or welded. Until the 1980s, the only practical way to place a fixed attachment was to put it on a band by welding or soldering. Then the band could be cemented to a tooth. The second type of attachment are brackets. Each bracket is made up of a bracket base, a stem with a bracket slot, tie wings, and some form of a hook. Brackets may be classified according to the material from which they are constructed into metallic, for example, stainless steel, and non-metallic. They are known as aesthetic brackets that are made from composite, ceramics, or sapphire brackets. They can be also classified according to prescription, and we have known that prescription means the amount of built-in tip and torque. There are different prescriptions. The original is a standard edgewise with 0 in-out, tip and torque, and there is the Roth prescription and McLaughlin-Bennett-Trevisi, which is known as MBT prescription. And there are many other prescriptions as well. Another way to classify a bracket is according to slot size. There are two major slot sizes, 18 milli-inch and 22 milli-inch slots. The slot has a width and depth. The 18 represent the width of the slot, and the depth would be 25 milli-inch, and for the 22 bracket, the depth would be 28 milli-inch. Brackets may also be classified according to the ligation method, and by ligation we mean the method of securing the arch wire to the slot. It may be either conventional ligation, by using elastic or metal ligatures or self-ligating brackets. The self-ligating brackets utilize a permanently installed movable component that would entrap the arch wire. This short video shows the self-ligating bracket as compared to the conventional ligating bracket. Self-ligating brackets usually have lower friction as compared to the conventional ligating brackets. The other attachments include, but they are not limited to, buccal tubes that are used on molars. We can have single tube, double tube, or triple tube. There are also buttons that are mushroom-shaped attachments. They are used on palatal surface of the teeth to provide couple force or on partially erupted teeth. The eyelets that are also mostly used on partially erupted teeth. These photos show two different uses of the buttons. The photo on the left, where the button is attached to the palatal surface of the second premolar, it is used to provide a couple for derotation of that tooth. While on the right, it is attached to the labial surface of the lateral to bring it into the line of occlusion. These photos demonstrate the use of an eyelet to bring about an impacted canine into the line of occlusion. The second component of a fixed orthodontic appliance are arch wires. The amount and type of force applied to an individual tooth can be controlled by changing the cross-sectional dimension and form of the arch wire and/or the material of its construction. In the initial stages of treatment, flexible arch wires with good resistance to permanent deformation are desirable. For example, nickel titanium arch wires. While in the later stages, rigid arch wires are required to provide fine control over tooth position. For example, those made from stainless steel. Arch wires can be described according to their material, dimensions, and form. There are many materials that are used for making arch wires, including stainless steel, nickel titanium, beta titanium, etc. An arch wire dimension is usually expressed in millinches. 1 millinch equals 0.025 millimeter. So 16 millinch is around 0.4 millimeter wire, while 16 by 22 is a rectangular 0.4 by 0.55 millimeter wire. Arch wires may be described as full form, regular form, and standard form. There are many other forms, but these are the most common. The last component of a fixed orthodontic appliance are auxiliaries. There are many auxiliaries that are used with fixed orthodontic appliances, and we cannot list them all in this lecture, but we will highlight the most common. The first type of auxiliaries are ligatures. These are used to secure the arch wire into the bracket. They include elastomeric modules and ligature wires. The intraoral elastics are available in different sizes and strength to provide intra and interarch traction. These elastics must be changed daily by the patient, and they are often described according to their use. For example, class 2 elastics are used for the correction of class 2 malocclusion. This short video shows how class 2 elastics are used. So they are attached to the hook of the canine from one side and the hook of the molar from the other side to correct the class 2 malocclusion. while class 3 elastics are basically the same type of elastic, but they extend from the upper 6 hook to the hook of the lower canine to correct a class 3 malocclusion. Another type of auxiliaries is the elastomeric modules, or it is known as the elastomeric chain or power chain. It is a chain of connected elastomeric rings that is used as a force-producing mechanism for orthodontic tooth movement. These chains can be either long, short, or closed. This depends on whether or not there is a distance between the rings in its passive state. This short video shows how elastomeric modules or power chain is used to close spacing between the teeth. Another type of auxiliaries are the separator or elastic separators. They are elastomeric rings of varying thickness. They are placed around the interproximal contact point to create the necessary separation for the placement of bands. Lastly, we have the lingual appliances. In these appliances, the brackets are attached to the lingual or palatal surface of the teeth. They are mostly used for aesthetic concern, where the patient refuses to have their brackets attached to the labial or buccal surface of the teeth. There are some problems associated with them, including some pronunciation difficulties that occur after insertion. The technique itself is difficult and time-consuming, and the working position is awkward for the orthodontist. This short video shows different orthodontic appliances. We have the metal appliance and we have the aesthetic appliance. And we can compare them to the lingual appliance. This is the bracket. And is attached to the lingual surface of the tooth. And we can see that it is more aesthetic as nothing is shown on the labial or buccal surface of the teeth. Thank you.